Hello friends, in this video we will study about the 8279 IC, which is known as the Programmable Keyboard Display Controller. In this video we will study about the pin description of 8279. So let's start with our topic. This IC 8279, it is also known as the Programmable Keyboard Display Controller. This controller, it is designed by the Intel so that it can interface a keyboard with the central processing unit. So for interfacing the CPU and the keyboard, this 8279 IC is used. So this 8279 IC, it is designed by the Intel to interface a keyboard with the CPU, and 8279, it is going to first scan the keyboard that if any key is pressed, and if any key is pressed in the keyboard, then it will send the function associated with that key to the central processing unit, that this key has been pressed by the user, and the CPU has to perform the function of this key. So it will scan if any key is pressed, and it then sends the relative function. So it then sends the relative response of the pressed key to the CPU and vice versa. So this is the function, or it is the use of this 8279 programmable keyboard display controller. So now let's just come to the pin diagram of the 8279. It is a 40 pin IC. So in the pin diagram, we will have the 40 pins. So let us first draw the pin diagram of 8279. In the ICs, because this 8279 IC, it is a 40 pin IC. So in the ICs, the numbering, it goes in the U direction, okay, in the form of U. So 1 to 20 here, and from 21 to 40 is here. Now comes to the pin number 1. This is This VSS, it is connected at the 20 pin. It is for the ground connection. That is why I have written here 0 volts. And this 40 pin IC, it is for the power supply connection where the plus 5 volt is connected. So these are for the power supply connections. Then we have RL2, RL3, RL1 and RL0. These are the read lines here. Then we have the clock input at pin number 3, then IRQ, interrupt request. Pin number 5 are RL4, RL5, RL6 and RL7. Okay. Then pin number 9, it is for reset. Pin number 10, it is for read. Pin number 11, it is for write. These are DB0 to DB7, which are the 8 data bus lines from DB0 to DB7. Then we have here A0, CS bar, BD bar, then out A3. This pin, it is for Cntl and STB, and this 36th pin, it is for shift. So this is the pin diagram of 8279 programmable keyboard display controller. These are RL2, RL3, then we have RL1, RL0 and 4, 5, 6, 7 pins are there. So there are the 8 pins for this RL. Then we have read, write, reset, clock, interrupt request here. Then the data bus, the power supply connections are there. Then Cntl and STB strobe. Then shift. Then SL0 to SL3. Then out A0 to A3 and out B0 to B3. Then we have BD bar, CS bar and A0. So let us study the pin description of all these pins. We will study one by one all the pins, what they describes. Okay. First, we will start with the data bus lines DB0 to DB7. There are 8 bidirectional data bus lines which are used to transfer or receive the data from the CPU. So these are the 8 data bus lines. Bidirectional because the data can be transferred in both the directions. So these lines are bidirectional data lines. So they are used to transfer the data to and from the CPU. Now next come the clock input. This clock input, it is used to generate the internal timings which are required by the microprocessor. So internal timing and control signals, they are generated by the clock input, and these timing signals, they are used by the microprocessor when it is interfaced with the 8279 keyboard controller. Then we have reset. Reset pin, as its name suggests, that it is used to reset the microprocessor. Next pin we have is the chip select signal, chip select pin, which is the CS bar. This line, it is known as bar, and when this bar is there over a signal, it means that this signal, it is an active low signal. Means its value is active when it is equal to 0. So this is an active low signal, and it allows to read and write the operation, to perform the read and write operations. Or we can say that when this chip select signal, it is active low, it means that this 8279, it is interfaced with the microprocessor. This chip is selected, and now all the operations like read and write operations, they can be performed with the chip. If this chip select signal, it is it is low, sorry, means it is active high, but it is its value is high, means it is equal to 1, then it means that this chip is not selected, and no operations can be performed with the 8279. So it is basically to select the chip, that is why it is known as chip select signal. So if you want to perform the read and write operations with the keyboard controller, then this chip is set to low, means it is set to 0. Otherwise, it is set to high. Okay. Then we have the pin A0. So this A0 pin, it indicates the transfer of command and status information. And when this pin it is low, it indicates the transfer of data. It means that this keyboard controller, it is basically transferring the information of the keyboard to the central processing unit. So this pin, it helps in indicating or transferring the information from the 8279 to the microprocessor. So when this pin it is low, it means that the transfer of data has taken place. Now next pins in the pin diagram, we have the read and write pins. RD is for the read and WR it is for the write. So this read and write signals, these lines, they allow the read and write operations to be performed by 8279, and these signals, they enables the data bus buffer to send and receive the data over the data bus, because the transfer of data between 8279 and the microprocessor, it takes place through the data bus, and this data bus, it has a data bus buffer which stores the data. Now this read and write signals, they enables the data bus buffer if it wants to send or receive the data over the data bus. Next lines we have is the IRQ, which is the interrupt request. This is the interrupt request signal. So it goes high when there is data in the FIFO sensor RAM. So whenever the data is to be transferred from the keyboard, that is the information about the keys which are pressed, that information is to be transferred by the 8279 to the microprocessor. Then that 8279, it is going to interrupt the microprocessor that I have the data and I want to send this data to you, that is to the microprocessor. So this interrupt request signal, it will go high when there is data in the FIFO sensor RAM. FIFO means first in first out, and sensor RAM, the 8279, it has RAM in which all the data is stored. RAM is a type of memory. So first in first out means the data which is first put into the memory, that will be taken out first. Okay, so this interrupt request signal, it will go high when there is data available in the FIFO sensor RAM, and whenever this RAM, it is read by the microprocessor, then it will interrupt request signal, it will go low. Okay. Next, we have the power supply pins VCC and VSS. These pins are for the power supply connection. VCC is for the plus 5 volts power supply and VSS is for the ground connection. These are ground and power supply lines of the microprocessor. Next, we have SL0 to SL3. So this SL0 to SL3, these are the scan lines which are used to scan the keyboard matrix and display the digits. These lines can be programmed as encoded or decoded using the modes of the 8279s. So these lines, they are used to study the keyboard matrix is the inside circuitry of the keyboard. So if you want to read it, then these lines are used. Next we have RL0 to RL7. Just we have the SL0 to SL7, which are the scan lines. These are the return lines. Which are connected. So these are the return lines which are connected to the one terminal of keys, while the other terminal of keys is connected to the decoded scan lines. So one terminal of the key is connected with the return line and one terminal is connected with the scan lines. These lines are set to 0 when any key is pressed. So the main function of this 8279, it is to tell the microprocessor that a key has been pressed by the user, and the response of this key will be done by the microprocessor, or the function associated with that key has to be performed by the microprocessor or the central processing unit. Next pins we have are the shift pin. There are various modes of the 8279 IC, and one of the mode is the scanned keyboard mode. So in this mode, the shift input line status, it is stored in the every key code in the FIFO RAM of the this 8279. So this shift line, when it is pulled to low with a key closure, it is pulled up internally to keep it high. Okay, means the high and low of the keys, it is decided by the shift input line. Next we have is the control, which is Cntl, and strobe input mode. This is control, strobe input mode. Now this line, it is used as a control input to the 8279. Now, whenever a key is pressed or closed in the 8279 in the keyboard, then the status of this control input or this pin, it is stored in the FIFO memory of the 8279. It is a strobe line that enters the data into the RAM. Okay. So that is why it is known as the controlled and strobed input mode. So whenever a key is pressed, then the status of that key that it is pressed, it will be stored in the FIFO RAM. Okay, and this line, it enters data into the RAM. Whatever data is at, it will be stored in the RAM when this line is high. Next we have BD, which is the blank display. So this pin, it is used to blank the display it during the digital switching. Okay, so whenever it is used to blank the display, next we have the out signals, that is from out A0 to A3 and out A4 to A7, B0 to B3. One is for the A port and one is for the B port. So out A0 to out A3 and out B0 to out B3. So these out A0 to A3 and B0 to B3, these are the output ports for the two 16x4 or one 16x8 internal display refresh registers. So these are basically the output ports for these registers. Now data from these lines, that is from these ports, it is synchronized with the scan lines to scan the display and the keyboard. To read or to scan the keyboard information, then these lines are synchronized with the scan lines of the keys which are in the keyboard, because one terminal of key it is connected to the scan lines and one terminal is connected to the return lines. So if we want to read the status of the key, that whether it is pressed or not, then that status it is transferred or it is synchronized with the data from these output port lines, which are the ports for the refresh registers of the 8279. So this is the pin description defining all the 40 pins of the 8279 programmable keyboard display controller. So I hope that this topic is clear to you. Thank you.